So I'm not too sure how many people will be here today, but we are live for some pure maths. Normally maths live, at this time of the year, we see nice 400, 500 numbers. Right now, we're just seeing, I don't know how much you'll see. Right now, I'm seeing 0 on live for the pure maths. Pure maths people are there. Just type Y in the chat if you're there. If it have nobody here, well, we could just, go and sleep or something. And the reason I'm saying we is because I have one of my tutors here with me today, Nalini Prasad. She's the best person in mathematics you would ever see. And Nalini is one of the reasons why my maths class is so successful. One of the tutors who does a lot of work behind the scenes. So I'm going to add her now. And y'all could say hello, Miss Nalini. So I'm seeing Samantha. I'm not too sure you want to be in this live. I'm seeing people from the CSEC AdMaths class here in Nalini. So all right, look, the pure maths people arrive. Javish, Sedan. Not much, 50 something. We can live. You tired, boy? Well, we're going to do some calculus, and you all will help us walk through this calculus. Yeah, we only doing the, this is past paper questions and calculus from 2010 to 2021. This would be best watch on an iPad or something, but if you're on your phone, so you might be able to see it like that. So I don't want to talk too much at the start of the video. Let's just get into it, and we'll see how good you all are in the calculus game. So you need to evaluate the integral of x minus 1 over x, all to be squared between -1 and 1 with respect to x. So that's definite. This came in June 2010. And then using a substitution where u is equal to x squared plus 4, or otherwise find the integral of x by the square root of x squared plus 4 all over x squared plus 4 all to be square root. And this is with respect to x as well. So this is some integration hustle. Rate out of 10, how you feel you would do in this question. If this would pop, it's actually 10 marks. If this popped in your exam, how much marks you think you're going to get? This is, I want to say again, this is pure maths for Form 6 students, lower 6. All right, Nalini, you're going to write on the screen here?
Yep.
So I can take a little fight with the first question, and you will take a little fight with the second question, right? We'll see how this goes.
No problem.
So we're integrating -1 x plus x minus 1 over x. I'm using Jamboard now, so I may not be as quick as I normally am. All right, so people saying they would get 9, 8, 4, 6, 7. 6 mean again the first part out. So what would be your approach to solving this one, people? What would be your approach to solving this one? Integrating this all together as 1 to b squared. Integration really would like differentiation like that. So my approach to this question would be, I just get something off my screen here, and it actually drawing. My approach to this question would be to, can I make my pen a little bigger? Yeah, this is looking a little better. My approach to this question would be to expand. Expand. What do you think, Nalini? Expanding something good here?
Yeah.
So expand first. Expand first. I'll write in the red then. Expand first. And if I expand this first, I'll get x minus 1 over x multiplied by x minus 1 over x. And this will be, we want x squared. We want positive 1 over x to be squared. And we want 2 times this subtracted. So wait. That's just 2.
Yep, -2.
That's just -2. Yeah, because I'll get x by x. I mean, x by negative 1 over x, which will be negative 1. And then I'll get a next negative 1 here. So I'll get negative 2. So when I expand, this is what I get. What y'all think about that? So this is the first order. I expand. Then this is easier to integrate. So I expand first, then integrate. And if I integrate x squared minus 2 plus 1 over x with respect to x, I could think of integrating all of them separately. I could think of this as integrating all of these separately with respect to x, right? So I'm going to get integral of x squared is x cubed. This is between negative 1 and 1, so there's no plus c. X cubed over 3 minus 2x plus, by the way, the first thing we should do is double check this on our calculator. So I'm going to swing back for that with my calculator just now. X cubed minus 2x, what else? Plus, well, this will be, what's the integral of 1 over x? What's the integral of 1 over x, y'all? This is x to the power of negative
1 over x squared. It's supposed to be 1 over x squared as your tilting.
Right. Oh, what's it also? Okay, it's 1 over x squared. Well, this one easier, x squared. Can't remember seeing the integral of 1 over x for them, but I think this is supposed to be able to do that too. So it's actually x squared. 1 over x squared was my tilting. Thanks, Nalini. So this is x to the power of negative 1. If I need to integrate that separately, what do I get? So hopefully you all could agree with me. How is lasso things here, but I guess I'll just erase. Now this should be negative 1 over x. Are you good with that? So this is the answer here when we integrate everything. And we want this between the limits of negative 1 and 1. So if I could just lasso this and get this on the next page, can I do that? I'm trying to copy something. Just bear with me. I don't really use this. I use Dosary. I really don't want to have to go through writing this again.
Mm-hmm.
Can I? Is that a thing that you can do? Use the circle? Doubt. This tool is the select tool. But I just don't know how to use Jamboard that good. Yeah, so somebody saying plus 1 over x and negative 1 over x. Well, this will go up by 1. Why am I not getting to copy right? Anybody know the reason why it's negative here and not positive? So with integration, this power here will go up by 1, so it'll go to negative 1, and then you need to multiply by the new power. So this will change the sign here. Now, if it's blurry, just change the definition on your YouTube. All right. So since apparently I don't know what I'm doing in this Google Jamboard, x cubed over 3. The live must go on. The maths must go on. minus 2x minus 1 over x between -1 and 1. So we have this, and with this is just a substitution. So when you substitute, you'll have the 1 being substituted in here. So my aim in life is to go through this really slowly and be like try to explain everything as much as possible. -1 to be cubed. This was 1 to be cubed too, which will still be 1, right? Over what is it? 3 minus 2 by 1. Ideally is the bigger minus the smaller, right? So this is -1 to be cubed over 3 minus 2 by -1 minus 1 over -1. What is this answer going to be, class? So this is where I would use my calculator to verify the answer. You'll have shift. You'd use this. Yeah, the reason I'm using this is so that Miss could interact with the same thing too. But don't worry, the next time we come on, we have it a little quicker. 1, -1. I forget what the function was. What was it? Was x. You all know you could do this, right? Minus 1 over x. This is called securing the bag. And all of this was to be squared. Okay. I need that somewhere. Yeah, I need to close up this entire thing. I think. I'm doing it on my calculator here. This calculator could be glitching. The answer is 8 and 3. Y'all get 8 and 3? So once again, if you're seeing it blurry, you need to change the setting on your end. Y'all get 8 and 3 with this? Between negative, what was it? Was it x minus 1? Oh, it was actually 1 all over x. Calculator struggling to do this in anything.
Yeah, I realize.
Yeah, so the
Because
calculator.
it's supposed to be -16 over 3.
Yeah, -16 over 3. -16 over 3 when you do this. But this is a question like no more calculator in degrees. This is and that wouldn't matter for this. This is a question the calculator not working it out. That's really interesting. I wonder if it was a special way I need to put this in. So like with the 1 over x, my calculator not working it out. Normally you can integrate between limits on your calculator. But I don't know, that 1 over x they're giving us a math error. The method that the calculator is using. So when you go through this, you should end up with anybody getting 16 over 3 when they go through this. You put this in your calculator to get it out really fast. And you will get -8 over 3 minus 8 over 3. -16 on 3. Why isn't it chat if everybody understand that? You're all kind of silent right now, as pure math students as be. But I want you all to make sure that you understand everything. So if you have any questions, let me know. Yeah, so normally you should be able to put this in your calculator just so and integrate, but this 1 over x fight in the calculator by. So I'll take a little look at that. All right, Nalini. So we have this substitution question next.
Okay, so you're required using the substitution u equals x squared plus 4, or otherwise you can find the integral of x root of x squared plus 4 x root of x squared plus 4 with respect to x. So it's easier using the substitution u equals x squared plus 4. So u equals x squared plus 4. We find the differential of u with respect to x, so that's du dx.
All right, so we differentiate in one time.
Right? So x squared, bring down the power, subtract 1 from the power, so that will give you 2x, and while constants go away. Then you make the x the subject, so it's 2x multiplied by dx is equal to du. Making dx the subject, you divide throughout by 2x, so it's 2x, dx is equal to du divided by 2x. Right, so we don't have to worry about the limits because they didn't give us any. So we're going to put this substitution into this integral. I'll just do it right here.
How do you know which term to substitute, says Jonalia? Well, they gave us it in this round.
Yes.
They gave us it this time.
And normally it is be in brackets. In an integral, normally you would see it in brackets and you would try using that as your substitution.
Can we purchase this calculator for exam? Of course. People have done it. So Mom is that she substitute. This was given to us. This was given to us. This part here. Let me use the pointer thing. Yeah, so this was given to us, and we differentiate and then separate our variables. So we're going to be able to get rid of this variable with a nice substitution and integrate with respect to u. So keep going.
Right, so we're going to substitute dx as well as x squared plus 4 as u in here, and you would begin to see that we don't need to substitute x, it will cancel out. So substituting will give x root of u is equal to x squared plus 4, so we substitute that into here. Dx is du divided by 2x, so that's du all over 2x. And you would realize that this would cancel out, x terms cancel out. Let's write it back. So it will be the integral. Root of u is the same thing as u to the power of a half. You would have a half in here as well, d with respect to u. So you can put constants outside the integral. So you have a half integral of u to the power of a half with respect to u. So differentiating with respect to u, we leave the constants. Integral of u to the power of a half, but you add 1 to the power, divide by the new power. So u, a half plus 1 will give you 1.5. So that will be 3 all over 2. Divide by the new power, which is 3 over 2. du. So we can decrease the number of fractions that we have. So dividing by 3 over 2 was essentially multiplying by 2/3. Multiply by 2/3. There was no need for me to put this back. We already integrated.
Yeah.
And we've needed to make sure and put in our constant of integration.
Nice.
So, I don't like how I have that written. You can just leave it like this. So you can see clearly that a half divided by 3 over 2 is the same thing as a half multiplied by 2/3 u to the power of 3 over 2 plus the integration constant plus c.
All right, so
So
you're
those are
supposed to be able, sorry to interrupt, Mister. You're supposed
You
to
go
be
ahead.
able to follow through with all of this, but I know it has some people, I've seen it in the chat too. Some of us are struggling. Slow down, please. Begging for slow down. So,
Oh my gosh.
yeah, no, that's good speed. So, what happened here, boy? We want to integrate this, but we can't really integrate this just so. What is what we could call a composite function, right? It's two different kind of functions. We didn't really know what to do when integrating that. But there's integration by substitution, which is the method we really use for CAPE Unit 1 Pure Maths. And the idea with this, don't worry, stick around. We're going to be doing a lot of this today. You're going to see that we're actually going through all the past papers here. And we now start in 2010. Is that you take the whatever they give you, before you do the substitution. Yes, we're going to do the substitution part here. That's what Miss do right there, right? But before we do the substitution, we differentiate. You differentiate. So we differentiate this. Everybody understand how we get this? And the aim is to get du by itself. So when, dx by itself. So when we get dx by itself, is actually two things is really be substituting in these questions. And think about it. It's two things is be substituting, this and this. What the thing that if you have to substitute and the with respect to x, because you need to integrate with respect to u now. So this dx here is actually the change of u, with respect to u, divided by 2x when we differentiate and rearrange. Are you good? Are you understand what I'm saying there? Why isn't the chat if you got up to that point? So what Miss did was she substituted the u, she substituted for dx, and then, well, this x interacted with that x in a lovely way for us, which is what you expect to happen. And you'll just end up with something that you could integrate with respect to you, something in you. And I see Javish asked the question on the second line, how you getting half? Miss, you could just tell me how we get this half here.
So du dividing by 2 is essentially multiplying by a half. So taking out the division by 2, you can take it out as a constant as multiplying by a half. Right. So it's a half multiplied by the integral.
Right. And then when you're integrating a half, you add 1 to the power. So you get the 3 over 2, and then you need to divide by the 3 over 2. But dividing by 3 over 2 is the same as multiplying by 2 over 3. All right. Are we finished here? Are we finished here, Miss?
No, we have, well, let's first simplify. So a half by 2/3 will give you a third u to the power 3 over 2 plus c. And we're still not done. We can substitute back for u. Right? So substituting back for u is equal to x squared plus 4 to the power 3 over 2 plus c. Right? C is your constant of integration.
And that's it. 10 marks. So in the exam, you'll feel you could collect them 10 marks now? This was the first question. This is the second question. That was June 2010. So let's go on and see what's the next difference. June 2010, question 6. Difference, well, one was 5, part C, and one was 6. Okay. So once again, I'll take the first one, you take the second one. This kind of working out with you getting the harder ones all the time. we can maintain this right through. All right, so differentiate with respect to x. Y is equal to sine 3x plus 2 plus tan 5x. And then you need to differentiate a nice little quotient here. So we differentiate in this, which is very tough, very tough. So what we had, let me just write it in the meanwhile. Y is equal to sine of 3x plus 2 plus tan of 5x. Now in CX here, you didn't really need to know how to differentiate tan x. You didn't really need to know how to differentiate tan of anything, but in CAPE you kind of need to. And there's this in CAPE, I believe you can just differentiate directly. You don't need to use the little segue that we use in AdMaths, where we have to put u and you do what is called the chain rule. You do your chain rule, but I'll still show the chain rule method if you're really quick. I might be the extra student, and I feel I might just do a little slide chain rule on the side just in case now. But let's do it the fast way first. So what we want? We want dy dx. And this is going to be equal to, when we differentiate sine, we'll get cos. But before we do that, we should be examining the brackets, because we have to multiply by the differential inside the brackets, right? So when we differentiate inside the brackets, this will go by, that will go by, well, the differential of 3x is just 3. So there's going to be a 3 out here, multiplying by the cos of this. Why isn't the chat if you all agree with that? When we differentiate tan x, we get sec squared x. So similarly, you're going to see sec squared 5x here, and you're going to have a little 5 multiplied, because once again, when we differentiate this separately, you end up there. So this is it straightforward. One line is a one-liner. But if you're using the chain rule, it'd be like, let u be equal to 3x plus 2 du dx is equal to 3. Let so therefore the y is equal to sine. It kind of have 2 chain rules to use now. I was looking for a shortcut, but y is equal to sine u. So dy du is equal to cos u. Therefore, in this case, dy dx for this term would be this multiplied by this, which is really dy. Why isn't the chat, if you know what I'm talking about, this making sense here? This is dy du. Dy du multiplied by du dx, or the other way around. So I'll have 3 cos u equal 3 cos, and you bring back all the u now, 3x plus 2. And you do the similar thing for this. All right. Good luck on my side. AdMaths me have. All right. Blessings. Why do we put back 3x plus 2 in the second line? Right. This goes nowhere. That's just how it works. This is sine of this function, sine of f of x, sine of a function inside here. So the only thing that we need to realize is that we also need to multiply by the differential of this function there. What y'all think about that? This section here, where my mouse by, this section here was just like, if you're using the chain rule, how you'd get this answer. But you see how excessive this is. All right. Rate out of 10, how much you understand this? This is an easy one, so y'all should be good with this. Nalini?
Okay, so part 2 of it asks you to differentiate x squared plus 1 over x cubed minus 1, right? So y is equal to x squared plus 1 all over x cubed. I was trying to use the pen. X cubed minus 1. Right? So this is supposed to remind you of something. How would we differentiate this? Quotient rule. Right, so it's of the form y is equal to u over v. So let's state what u and v are. We say let u be equal to x squared plus 1, and we let v be equal to x cubed minus 1. Right? So, using the quotient rule, we know that we have to find du dx and dv dx. So du dx, we bring down the power and minus 1 from the power. So x squared becomes 2x, and the constants go away. dv dx, it would be bring down the power 3 x squared, well, x cubed. 3 minus 1 will give you 2, so you get 3x squared minus 1. The minus 1 goes away, right? So you have u, v, you have u dx and dv dx. So stating the quotient rule, you would have dy dx, right? We start with v du dx minus u dv dx all over v squared, and then you substitute accordingly.
Jeff, if you're asking that question, you're under real tension, bro. If you're asking what is the quotient rule, problems in the dance. Now you can't be asking that, bro. How you can be asking that and doing pure maths? All right.
A trick to help you remember the quotient rule. Sometimes students mix up. They start with u dx minus v. It's v du dx minus u dv dx. So I use this v here and this v here. So it starts with v. Starts with the later one.
Right.
Right. So you're going to substitute accordingly.
And the next thing is, I remember when you substitute, don't try to cancel whatever you have there immediately like that.
That's exactly right.
Yeah.
Right, so v is equal to x cubed minus 1 dv dx, that's du dx. Right? Du dx x squared plus 1. Oh, no, it's not. It's 2x.
Du dx is 2x, right?
Minus u, which is x squared plus 1. And dv dx, which is 3x squared. And this is all over v squared. V squared is x cubed minus 1.
Nice.
All squared. Right, so you're going to take your time and you're going to expand these brackets. I want to try to do it on one page, so I'll come to this side. So x cubed by 2x will give you 2x to the power 4. Minus 1 by 2x will give you 2x. Minus, we have minus 1 by x squared by 3x squared, which will give you 3x to the power 4. Then you have minus 1 by positive 1 by 3x squared, will give you negative 3x squared, all over x. Well, you don't need to interfere with this. This is best represented by itself here. X cubed minus 1 all to the power squared. Right? So can we simplify? Yes. Because in the numerator you have a 2x to the power 4 minus 3x to the power 4. And that will give you minus x to the power 4. We want to go in terms of like from the highest power to the lowest power. So let's look at the x squared term next. So you take the x squared term. That's minus 3x squared. Make sure and take the negative sign with you. And you're left with minus 2x all over x cubed minus 1 squared. You can leave it like that, or you can take out the minus x from it. So taking out minus x from each of the terms, you get minus x into x cubed plus 3x minus 2 all over x cubed minus 1 all squared. And that is how you differentiate using the quotient rule.
Nice. So I'm not really seeing it. Hey, Mrs. Ren, can you do a video streaming going through logarithms like what you did for trigs and admaths? Well, we eventually going to do some logs, so no worries there. We'll probably do it for admaths and for pure maths. Right. So any rate out of 10 how much you'll understand this. Sometimes you get some little interaction between the numerator and the denominator here. I'm not really seeing anything. That could just probably stay as it is. And that will be a healthy 4 marks for you and your people them. And the first part was 3 marks, this differentiation here. Easy thing. All right, so everybody like easy thing. So I seen a next AdMath student in the dance, but this is a very special AdMath student. Let's see if she can keep up with the pure maths. All right, so the function f of x satisfies, okay, f of x with respect to x integrating between 4 and 1 is 7. Find, okay, the integral between 1 and 4, 3 by f of x plus 4, all with respect to x. So you need to ask yourself, what is this question? What the hell is this question really testing you on? What is it testing you on? So this question is really testing you on the rules of integration kind of way. So like if you're multiplying by a constant, what happens? If you add on a constant, what happens? You already know what f of x with respect to x integrated between 1 and 4 gives you. And sometimes they may change the limits or put numbers on the outside. So you need to know what you think would happen, or like they might have in between limits, so that something like that from like 1 to 3 and then 3 to 4. There's a multiple choice question in pure maths that tests you on something similar to this as well. So in this case, it's paper 2, so you need to show your working. You're not just going to shade the answer. So what we gonna do, boy? I would say, well, hit them this one time, do a little penmanship right over the same thing there. The integral of between 1 and 4, fx with respect to x is equal to 7, is that. So you hit them back that. Then you say, then we'd write back the question 1 to 4, 3. Anybody ever answer it? Somebody say 45. 3 f of x plus 4 with respect to x. All right, so this is what we have here. And we want to kind of just break this down so that we can have a nice little explanation of what's going on. So we can separate this like into 2 integrals. Maybe I could use another color here. We could separate this 1, 4, 3 f of x, and then have a next one with just the 4. Both of these are with respect to x, right? So I know I could grab this and move it across like that. But both of these are with respect to x. Anybody have any questions there? So this question is just testing us on the rules of integration. We separate it. That's one rule. And this tree could take a little vacation on the outside. So instead of writing that over, I'm just going to snag that tree, if I can, and carry him on the outside there. You go and climb over there, bro. So you understand what's happening? That's the next rule there. And now, hold up, we could deal with the 4x, with the 4. Because when you integrate a constant, we get something. So this is 3 times, by the way, this is just 7. Because this is this, right? So plus, and this is just 4x between 1 and 4. Why isn't each other if you'll agree with me? Because when I integrate 4, I get 4x, right? When I integrate this, I get that. So substituting with the 4, I'll get 21 plus 4 by 4 is 16 minus 4 by, right? So that's 12. 21 plus 12 is 33. And I'm seeing Miriam had that a while ago. Molly already had it too. And someone is spamming, so Javish can handle that scene. All right, so what y'all think about that? Rate that 1 out of 10. Or you can do this question. Using substitution, well, Nalini, here's the nice, easy one for you as well. Using substitution, evaluate. Oh, another substitution. So we're going to see our next substitution at work here.
Okay. So we're going to use a substitution, u equals x plus 1. But first, let's write what we're required to find. So we're required to find the integral of 2 by f of x plus 1 between the limits of 0 and 3 with respect to x. So we're given the substitution u is equal to x plus 1. So we're going to use that. Right? So let u be equal to x plus 1. We're going to differentiate with respect to x. So we're going to differentiate u with respect to x. So that's du dx. I realize y'all aren't seeing what I'm writing. Right, so u is equal to x plus 1, du dx will give you 1 dx, making dx a subject, will give you du. Right, I hope everyone followed me there. So we're going to put that substitution into here. Right? So putting the substitution into
Yeah.
So if you could just right. So before we substitute, we need to find out what the limits are. So when x is equal to 0, we need to find out what u is. So when x equals 0, u is equal to 0 plus 1, which is 1. When x would be equal to 3, u would be equal to 3 plus 1, which is 4. Right? So those are the limits in terms of u. So let's now substitute. Right? So we have the integral between 1 and 4 of 2 f of u du. Right? So let me just explain how I substituted. The limits, when x is 0, u equals 1. Right? When x is 0, u equals 1. When x is 3, u equals 4. When you have x plus 1, you substitute 2u, and we found the x is equal to du, so we substitute the x as du.
Nice.
Right? So it's now to integrate. Well, f is a function. So first, let's bring the constant outside of the integral. So we have 2 integral between 1 and 4 of f of u du. Now, does this here look familiar?
That's this guy.
What does that looks familiar to anyone? Right? So it's from part B, part I. It's from the question. So it's supposed, this here is supposed to look familiar. Right? What we're giving in the question was this, that the integral of f of x between 1 and 4 dx is equal to 7. So u and x are variables, so you can interchange them. right? So 2 multiplied by 7 will give you 14, right?
Nice. Understanding of this out of 10. Go ahead, read. So what we did, we had this before, which tested your use of how integration works. This tested you on substitution in a kind of clever way here. You substituted and you just hope for the best after you substitute that these limits would sort itself out, and it did. U was equal to anything x is plus 1. So when you substitute the upper limit, you get the 0 to you get the 1 to 4 actually, because when you substitute the lower limit, you get the 1. So you get the 1 to 4 thing coming up again. You get the 2 come out, and it doesn't matter if I have u, v, x, anything. The function says once I have x with respect to x, once I'm integrating anything with respect to itself between 1 and 4, this function will always give me 7. So it really doesn't matter if I had vxu. So I have the integral of f of u with respect to u between 1 and 4. So that is just 7. That was from part 1 or part I. Yeah, part 1. And then 2 by 7 is 14. Why is in the chat if you all understand? So the next part of the question, and we do that kind of thing where I do the first part and miss do the second part, which kind of leave it miss with the harder parts, but I didn't choose this life. find the coordinates of, and by the way, if you in case you're wondering, this is Miss Nalini Prasad. She's one of the top tutors here at the Student Hub. In the diagram below, not drawn to scale, the line x plus y is equal to 2 intersects the curve y is equal to x squared at the points P and Q. Find the coordinates of the point P and Q. Lovely. So I need to find the coordinates of intersection between a line and a curve. And the curve is y is equal to x squared. And I believe everybody here in the chat can do this. And then we need to calculate the area. So after you find the points of intersection, we're going to use those x values and integrate with the curve and the line and do a little subtraction something of the sort, right? So let's see how we do this question. First, find the points of intersection quickly. So finding the points of intersection. Keeping in mind that the curve was y is equal to x squared and the line was y is equal to 2 minus x. Just rearrange the line one time. Y is equal to 2 minus x. Negative 1 is the gradient. Therefore, we have a situation where x squared is equal to 2 minus x at intersection. I'm just equating these two, right? And then bringing across everything, we'll have x squared plus x minus 2 is equal to 0. We'll have a quadratic taking place here. And hopefully the quadratic is solved using this. So either x is equal to 2 or x is equal to negative 2, sorry, or x is equal to 1. So why is in the chat if you all understand that? So you have negative 2, 1, and that seems to we have some evidence of that taking place here. So this is like the the coordinates of the point of intersection. So when x is equal to 1, y is equal to 1 as well, according to this. So you have 1 as one of the points, and when x is equal to negative 2, y is equal to 4, or negative 2 to b squared, according to this. So negative 2, 4 is another point of intersection. Rate how much you understand this out of 10 before we go on to the next part. Once again, this is probably maths for CSEC. Could probably see this question. So we just equate the two, and you get a nice handsome 5 marks there. But now we need to calculate the area of the shaded portion. Nalini?
Okay, so I'll ask you to draw it for me because you have better drawing skills.
Oh yeah, and plus I had the iPad. So
yeah,
this.
So I can easily show which area that we're trying to find and how we're going to find it.
All right, no problem. She says I have better drawing skills, and then, you know, this is not the program that I normally use. Is that good enough? We have P, we have Q. Yes. Y is equal. Yeah, so I guess you can take it from here.
Right, so the area of the shaded region is this area here. It's this area here that we're trying to find. So we're given the point found in the first part that the point P is -2, 4, and Q is 1, 1. So that means that here will be -2 and here would be 1. Right? So I'm going to label it so that it'll be easier. So let's label this part here area 1. Let's label this part here area 2. And this part here area 3. Right? That's a little hard to see, but you got my drift.
Yeah, we see it.
All right. So to find the area of the shaded region, so when we're finding the area of something under, we integrate to find the area under the graph. So this line is x plus y equals 2, right? And yeah, x plus y equals 2, and the quadratic is y equals x squared. So to find the area, we would need to find, to see it, you need to find the area underneath the line between -2 and 1, right? So if we find this portion here, it would be the area between -2 and 1 under the line x plus y equals 2, right? So let's go ahead and find that. So let's take the area of all of them.
Right.
Right. So that's the area of A1, A2, and A3.
Got it.
Right. So what shape is this? Can anyone see the shape?
I will say it's a trapezium.
Right. So area of a trapezium is a half by A plus B, the sum of parallel sides, by height. So the sum of parallel sides, A would be 4, B would be 1, and your height would be 3. Right? So it's a half by 5 by 3, which would give you 15/2. Right? And that's the area of all of them. Now, the area of A2 and A1 and A3, that would be finding the integral between -2 and 1. So that area is underneath the curve. So we're going to use x squared with respect to x.
Got
right?
it.
Everyone understands how I got that integral? This would be the area between, this would be the area 1 and area 3. Right? So we're going to integrate this. We would get x cubed over 3 with respect to 1 and -2. So substituting, we would have 1/3 minus -2/3/3. Right? You can use a calculator to help you, but this would be a third minus 8/3 would give you
Is
positive.
Yeah, -8/3, yeah. Positive.
So yes, 9/3, which will give you 3. And that's the area of A1 and A3. And what we're trying to find is A2.
Got it.
So to find that, we simply subtract. So area of A2 would mean that 3 minus 15/2. So that's...
Wait, is it the other way around?
Oh, it's the other way around. So area of the 3 of them is 15/2 minus 3. So that's 4.5. Well, 4.5. We weren't given any units, so we'll just state unit squared.
Nice. All right, so let me just hit it back the walkthrough again.
Yes.
This one comes a lot. We weren't giving units, so we just say unit squared. Were we giving units? No, we wouldn't. So yeah, we'll just say unit squared. Well done, Isabella. Just say unit squared. Well, you know, this is just to go on a new page here, so you can see the Venn diagram a little clear. What Miss did was she find, if I use dotted lines here instead, there's really two areas in the question, this and then this little piece of area here. But we can find the area of this part. This is what they want, the area of that part, by substituting the area of the whole trapezium minus the area underneath this curve. That's the only tools you really have now. The tools you have in pure maths is like finding the area underneath a curve, finding the area underneath a line. So if you have two things and they want the area trapped between a curve and a line, or a curve and a curve, you need to go ahead and find the area underneath both. So the area underneath the line is really a trapezium, so we don't even need to do any integration or anything. That would be overdoing it. We just do the area of a trapezium. This side is actually 4. If you think about it, it went up to 4. And this side is actually 1. And the distance here between the parallel sides, you go up 2 and then you go up the next one. So it's 3. So 4, 1, 3. Area of a trapezium, half the sum of the parallel sides by the height. And we got that to be 15 on 2, which in my mind looks like 7.5. So I kind of vibes in 7.5 there. And when Miss integrated x squared, which is really easy to integrate between -2 and 1, which is finding the area underneath the curve, we got 9 and 3, we got a solid 3, which is nice. So if we want to find the area of the red part, the part sandwiched in between the two of them, we do a subtraction. The area of the whole trapezium minus the area underneath the curve, which is really the orange part. It kind of hard to see here. Let me see if I could just shade the orange part there, like that. Wow. We have a little paintbrush and thing we could use here too. So that part. Rate how much you understand this out of 10. We're going on to the next question. Next question is in 2011, so we just finished 1 year earlier. Wow, this pure math is not working out like that math. We just finished 1 year. Oh my gosh. So the curve y is equal to px cubed plus qx squared plus 3x plus 2 passes through a point. Nice. And its gradient at the point is 7. Beautiful. The line x equal 1. This is another line, cuts the x-axis at m, which we could find the coordinates of m very easily. And the normal to the curve at t cuts the x-axis at n. Wow, this is an extravagant question. It just wants the unnecessary small things. Find the values of the constant p and q. So that's the first part for 6 marks. We weren't given much where that is concerned. We have the curve y is equal to px cubed plus, so we have the 2 constants hidden in there. You all seen it, right? I don't need to zoom in anymore. We have the 2 constants hidden inside there, and we want those 2 constants. Just so. it passes through the point T is equal to 1, 2. So we could do a little 1, 2 substitution here and probably get maybe an equation. And then we could differentiate and its gradient at T, differentiate the equation so we can get the gradient function, what we call the gradient function. And then we'll substitute again. We'll substitute 1. But you can't substitute the 2. The 2 is the y coordinate. If we substitute 1, we expect to get the gradient. So substitute 1 and equate it to 7. Why isn't it chat if you understand the way forward there? In pure maths question, you kind of have to visualize a little roadmap before you start, right? I mean, you could go along happily, and you should go along happily in life. You might be going on the wrong road unless you plan ahead. So let we do the first part. So we have the curve y is equal to px cubed plus qx squared plus 3x plus 2, and t is the coordinates 1, 2. So when x is equal to 1, y is equal to 2, right? So if I do a little substitution here, we'll get 2 is equal to p by 1, and 1 is a really nice number to substitute, plus 3 by 1 plus 2. So I'm seeing here I'm getting 2 is equal to p plus q plus 5. So I have p plus q is equal to -3, and I can call that equation 1. That worked out really nice, really nice. Y'all seeing? Yeah, so I kind of aware when you're not seeing when I write and I have this up, but sometimes I'll just write it in the background and then bring up this. But you could always tell me in case I forget, right? Last time I went and leave it blocking Miss Nalini. So we have the equation 1, and then we're going to have equation 2 by differentiating. So let's use colors. The maths done hard already. We might as well make it colorful. So differentiating, we get dy dx is equal to 3px squared plus 2qx. Now keep in mind this is a constant, right? It's like a number, so we don't know what number it is, so we just putting it back. When we differentiating, this is what happens. Nothing extravagant. So it's like you're just leaving the p there. And then 3, and well, the 2 goes bye-bye. Constants disappear when you differentiate. And then we have when x is equal to 1, once again, when x is equal to 1, not y is equal to 2 this time, we have dy dx, and I think they said 7. Was it 7?
Yeah.
Dy dx is equal to 7. So we can do this substitution. So we have 7 is equal to 3p, and 1 is a beautiful number to substitute. 2q1 plus 3. So we have 7 is equal to 3p plus 2q plus 3. So 4 is equal to 3p plus 2q. And that's equation 2. So I can write it like this. 3p plus 2q is equal to 4. That's equation 2. So let me just go on the next page and transfer these two equations. And whilst I'm writing it all, y'all could just watch it with love and tell me what's the value of p and q. 3p plus 2q is equal to 4. So whatever method you're feeling to use here, use elimination, use substitution, use calculation. You can type this up in your calculator, but I guess there's an overkill. You could probably use it verify your answer when you finish. And if we multiplied equation 1 by let's say 2, we'll end up with 2p plus 2q is equal to -6. This is equation 1, by the way. And now we can subtract, and I'm subtracting here, and I'm seeing that p is so I'm subtracting equation 2 minus equation 1, right? I'm seeing that this will go, and I'm getting p is equal to 10. Y'all agree? And substitute 4 P in equation 1, we'll get 10 plus Q is equal to -3. So Q must be equal to -13. So we just like that, we found our answers for P and Q, and that was 6 marks. 6 marks for a glorified simultaneous equations question. What you had a small differentiation involved. And a small differentiation involved here, and a little substitution involved. So they're really rewarding you with the marks for thinking through the question. All right, so let's go on with part 2, and then I will do part 3.
Okay. So we require to find the equation of the normal to the curve at t. So at t, we have the point 1, 2. So at t, we have 1, 2. So the normal and the tangent, they are perpendicular lines. And what is special about perpendicular lines is that the product of the gradient, when you multiply them, you get -1. So if we have that the gradient of the tangent is 7, so the gradient of the tangent at t is 7, then what would be the gradient of the normal at t? So if it's 7, then it's -1/7, right? So when we're finding the equation for normal, well, it's the equation of a straight line, so it's of the form y = mx + c. So we have the value of m. We need to find, we can use the point t1, 2 and substitute it into the equation, and we will get our equation like that. So we have y minus y1 is equal to m by x minus x1. So we're going to use the point 1, 2, y minus 2 equals, the gradient is -1/7, x minus 1. Right? So we're going to expand our brackets on this side. So y minus 2 equals -1/7x. A negative by negative will give you +1/7. And then let's just put it into the form y = mx + c. So let's put the -2 on this side. So y equals -1/7x plus 1/7 plus 2. So 1/7 plus 2, it's the same thing as 15/7. So this is of the form y = mx + c. You can also, to get rid of the fractions, you can multiply throughout by 7, which will give you 7y is equal to -x plus 15. This is another way of writing the equation of a line. So either one is fine.
Niceness. And then the last part in this question, which is back to me, the length, this method not working out when we have 3 parts. the length of mn. The line x is equal to 1 cuts the x-axis at m. So we can find m, the coordinates of m. And the normal to the curve t cuts the x-axis at n. So you just found the equation to the normal to the curve. You do the little gradient trick here. You substitute it in this gradient intercept formula. So you find the equation of the curve here. So I need to just find where this curve cuts who? The x-axis. All right, nice. I feel I could live with this question. So we have the line x is equal to 1, cuts the x-axis. So this is part 3 now. It cuts the x-axis at, where does this cut the x-axis at, y'all? This cuts the, think about this line. This is the line x is equal to 1. So it will cut the x-axis at the point 1, 0, right? Cuts the x-axis at the point 1, 0. Why isn't it chat if you all with us here? You all understand everything so far? And then this line, 7y is equal to negative x plus 15, cuts the x-axis at, I could put the point here, but let me just show some working at when y is equal to 0. When you're cutting the x-axis, y is equal to 0. So I know 0, I'm just trying to find the x value then. So I will just get rid of this with 0, because I substituted 0 there, is equal to negative x plus 15. So this x is going to turn out to be 15. Bring across negative, both of them negative, so x is equal to 15. Or bring across the x then. Yeah, so x is equal to 15. Why isn't it chat if you're all good up to there? So we have the 2 points. This point, so it cuts the x-axis at the point 15, 0. We have the point 1, 0. We have the point 15, 0. And therefore, the length of the line. Now, you can use the equation for the length of the line, but tell me why you think that would be an overkill in this case. The length of, what they ask for, the length of the line? Length of mn. Think about it. It's on the same, it's on the x-axis. You start at 1 and you end on 15. So you don't need to go and use the root of x squared. That's a little, that's like using a machine gun to, I don't know, make a hole in the paper. You could just puncture the hole in the paper, right? So you're just going to say the length of the line is equal to 15 minus 1 is equal to 14 units. No units were given, like it's 14 units. Why is in the chat if you all understand up to there? You could read the question out at 10. We're going to jump into the next question. So we in the year June 2011 and we're doing question 6. And here we have part 1, which will be done by Nalini.
Okay. So for question 6, part A, part I, we need to find the coordinates of A and B. So we are given that A and B are stationary points. So when you see the word stationary, you want to find the differential f of x, right? So f of x is equal to x by x squared minus 12. Let's expand that. We'll get x cubed minus 12x. So we can easily differentiate it, right? So f prime of x, right? So when we're differentiating, bring down the power, minus 1 from the power, so you get 3x squared minus 12. So this is supposed to be that, okay, stationary points occur when this is equal to 0, right? Now we can actually pull out the 3 to get x squared minus 4. And x squared minus 4, you're supposed to see the difference of 2 squares in that. So you get 3 by x plus 2 by x minus 2. Right, so stationary points occur when f prime of x is equal to 0. So when f prime of x is equal to 0, we're going to find the values of x. So 3 by x plus 2 by x minus 2. Right, if you divide 3 out by 3, 3 cancels out, so you have x plus 2 by x minus 2 equals 0. So either you have either x plus 2 equals 0 or x minus 2 equals 0. And you would get x is equal to minus 2 and x is equal to 2. So we now need to find the y coordinate that corresponds to the x coordinate. So when x is equal to 2, f of x, well, f of 2, would be substituting 2 into here. So it's 2 to the power of 2 minus 12, which will give 2 by 4 minus 12, which is 2 by negative 8, which is negative 16. And when x is equal to negative 2. F of x, so f of negative 2, substituting wherever x is, negative 2 by negative 2 squared minus 12. It will just be negative of it, so negative 2 by 4 minus 12, which is equal to negative 2 by negative 8, which is 16. Right? So you have the point x is equal to 2, y is equal to negative 16. So looking at your graph, the point A would be negative 2, 16, and the point B would be 2, negative 16. Yeah.
Nice. And I find they was very generous with the marks here. You get 8 marks for working on that. Wow.
Yeah.
It's pretty be so generous with y'all in the next month. Hey, next month is exams. Whoa, when is the date for exams, Javish? So what we had to do, we differentiate, and the differentiation was we didn't need to do no product rule or anything. Yeah, you multiply and you differentiate normal. Don't go and product rule this, people. You expand and you differentiate normal, and then you get 2 values, and you can see that it corresponds, and everything here makes sense. So that's great. The next thing they're asking us is for the equation. Yeah, for the pure unit 1. For the equation of the normal to the curve at the point, yeah. And Mr. already differentiated there, so let me just copy that. F prime x is equal to 3x squared minus 12. And we want the gradient when x is equal to x squared minus 12. We want the gradient of this when x is equal to 0. So when x is equal to 0, we get in a situation where the gradient is equal to negative 12, because we substitute 0 there, that goes. Which doesn't look like that's the gradient on the graph, but apparently it is. So I guess it's really steep at that point. Negative 12 is kind of steep now. So anyhow, so yeah, the gradient is negative 12. What is actually the equation of the normal? So the equation of the normal, so since this is the equation of the gradient of the tangent, and for sure you're going to get something like this in your exam, tangent normal. You must get some little play like that in AdMaths and Pure Maths. This is 2011 question 6, gradient of tangent. So the gradient of the normal will be equal to negative 1 over negative 12. You invert and you switch the sign, negative reciprocal, we like to call it. So you get 1/12. And once you find the gradient of the normal, you basically find the equation of the line here, because if you're keeping your mind open and you're thinking about it, the y-intercept is just 0. So we don't really need to use the y minus y1 is equal to m into x minus x1. You can just write the answer now. Therefore, equation of line of normal is equal to y is equal to 1/12x plus 0. So we can just leave all that. Rate how much you understand out of 10. So they asked us to find the coordinates of each of the stationary point. We did that. And they asked us to find the equation of the normal to the curve at the origin. We did that. And now the area between the curve and the positive axis. Oh, the positive x-axis. So this side, this segment here. So Nalini is going to handle that for us.
So we're only looking at this side, right? Did I draw that correctly?
Yeah.
But we're looking at the area on the between the curve and the positive x-axis. So if you look at the graph, you realize it lies below the x-axis. So when we find the area, it will be negative. So you'll just take the positive of it. We need to find where it cuts the x-axis here. So the equation is y is equal to x by x squared minus 12. So when y is equal to 0, we can find the values of x. So x by x squared minus 12 equals 0. So it's either that x equals 0 or x squared minus 12 equals 0. Now, x equals 0, that will be this point here. X squared minus 12 equals 0, you have x squared is equal to 12, so x is equal to the plus or minus the root of 12. So this would be negative root of 12, and this would be positive root of 12. So we're going to find the limits between 0 and positive root of 12. So when you're finding the area under the graph, we're going to integrate. So area would be the integral between 0 and root over 12. I'm saying root 12. It's between 0 and root 12 of the curve, which is x by x squared minus 12 dx. So to get rid of these brackets, we can expand to root of x cubed minus 12x with respect to x. So we're going to integrate this between the limits of 0 and root 12. Right? So x cubed, integral of x cubed, well, we add 1 to the power, which will give us x4, divide by the new power, which is 4, minus 12x, we add 1 to the power, and divide by the new power, which is 2, so that's just 6x. So the limits are between 0 and root 12. We're going to substitute our limits into here, so it would be root of 12 to the power of 4 divided by 4 minus, well, 12 divided by 2 is 6, so it's 6x squared minus 0 to the power of 4 all over 4 minus 6 by 0. This entire thing would cancel to be 0. So with 12 to the power of 4, that's 12 by 12, which is 144 all over 4 minus 6 by 12, which is 12 by 6 is 72. Well, we can just 36 minus 72. So this will give us a negative number. But that's because we were under the curve, under the x-axis. So the area is actually positive 36 units squared. Yeah.
All right. Yeah. So you're negative because yours under the curve. So rate how much? All right. So I see Miriam had the answer here. I wish she could go over that. Well, I'll read it over. I wasn't really paying attention. I was watching the next question. Then I feel you had to do the first part in the next question, the substitution. I'm not too sure.
I was watching it, and I was watching it, and I didn't.
All right. Okay. Well, then I'll look at it then. I'll look at that question afterwards. I should have prepared for this a little better and actually watch the questions that I'm going to do. But I was like, ice cream in Springer, you know. So I can see what happens in that next question. Anyhow, so x squared minus, what we do, we integrate this curve. We expanded and we integrated nice, and we integrated between 0 and the root of 12. This was really nice though, because when you integrate when you substitute root 12 to the power of 4, you're getting something nice. You're getting 12 squared. So again, 144. When you substitute the root of 12 squared, you get in 12. So this part here, you could work out really nice on your calculator or in your mind, actually. What was the trick here? There was no tricks. There was no tricks. You just integrate this. Make sure you don't try and do any product something here. Expand, integrate. Expand and integrate. And we see questions. We already see like 2 questions like this for the day already. And we integrate between 0 and root 12. So this part just turned out to be 0, this part here, because substitution 0. So it's subtract 0. So whatever you have here was the answer. 36 minus 72, so it's negative 36. Because they asked for the area, the negative here just indicate that it's under the graph. So they literally say the area between the curve and the positive x-axis. So the area here is, we don't really give areas a negative quantity. The area here is 36 units, square units. So use the result. Now I did this question in a crash course already, but I forgot what I did. So let me see if I can remember. F of x between 0 to a is equal to that. To show that between 0 to pi, x sine x dx is equal to 0 to x minus x sine x dx. This is a quick question. Hence show that x sine dx is equal to pi sine x dx, x sine x dx integral between 0 and pi. All right, so I'm going to spend 5 minutes on this question. If I don't crack it now, I'll crack it right after the live and probably post it on the Discord channel. Let me just write it back. So we have the integral between 0 and a f of x. Why isn't the chat if you could do this question? B part 1. A minus x, yeah. Where a is a positive number. So 0 pi sine x, x sine x with respect to x. 0 pi minus x sine x with respect to x. So what I'm going to do is go blindly with it. Don't forget to press like on the video. Nice. So show that if you have this, it's the same as this. So we want f of x to be equal to this whole thing. F of x is this whole thing here, and a is equal to pi in this case. And this is okay. So I'm going blindly. So f of x should be equal to x sine x, and in this case we substitute in a as pi. It's a little sus, and we should see this should give between 0 and pi according to this. Where a, what's happening here? This is f of a minus x. I want to use my little highlighter thing. This is f of a minus x there, right? And a minus x is replacing the x in this case. So using the solution, why isn't it chatting for you? Understand what I'm saying? Using this solution that they give us here, they say given that, show this, right? That's the question. This was given, and we need to show this. So if we consider our f of x as the x sine x, and we consider our a as the pi, then we need to just put down this now. So f of a minus x would be a minus x here going in the brackets. Tell me if you all agree with me. And then we'll have sine of a minus x with respect to x. And in this case, a is actually pi. Pi minus x, pi minus x. So it's a 2 marks question, and we kind of reached the end already. So we're done. We're done because pi minus x is the same as sine of x. Since sine of pi minus x is equal to the sine of x, when x, that's for that, just that first quadrant there, sine is a mirror of itself, pi minus 90 minus x. Yeah. So the first and second quadrant mirroring each other there. So this is 0 pi. This is a little bit of tricks, by pi minus x, sine x with respect to x. This work in here should give you the max. So the question is abstract because it has one-star letters and all kind of thing, but it's just a substitution. Let me know if you all understand what happened in here, boy. Let me try and explain it again one more time. So you had this was given. They say if you are integrating something, a function between 0 and a, it's the same as if you're integrating a minus x. So f of x is the same as if you're integrating f of a minus x between the same 0 and a, which is interesting. That's an interesting solution, interesting theorem or whatever. Anyhow, ignoring the interestingness of the term, they say they want you to show that this is this. Well, really, according to this, watch, the only thing they're really asking you here, stay with me, people. The only thing they're really asking you, compare it now. This is x sine x. This is f of x. So I should really see, it should really be pi minus, how to explain this in a really simple way, boy? How to explain this in a, so like if I have, okay, like if I have f of x is equal to x plus 3, then f of x minus 2 is really equal to x minus 2 plus 3 is equal to x plus 1, whatever. It's like you substitute the x here in this case now. You all saw what I did? So, right, great. So now if I have x sine x is the function, it's supposed to give me something with a minus x replacing the x. So I'm just replacing the x here with a minus x, and in this case, a is pi according to the limits. So I'm replacing the x with a minus x, pi minus x, and I also need to replace this with pi minus x. That's why I got this. This is what I'm supposed to get. So the only thing they're really asking you in this question is trigs. They're just asking you to say that this is this, according to the rules of trigs, that sine of pi minus x is the same as sine of x. That's all the question is asking you to say. You substitute and go brave, and which is what I tell my students to do too. Sometimes when you're seeing what to do, just go with what you usually do in a question like in that case. So I just substitute. Apparently f of x getting replaced by the whole of x sine x. So therefore f of a minus x, I need to replace this x and this x with a minus x, but a is really pi. So that's what I did. And then I compare to see if it's the same. This is what I was supposed to get. I didn't get that. But then I remember, oh, shucks, yeah. Sine of 90 minus x is the same as sine of x. Am I correct? Sine of pi minus x. Same as sine of x. Yeah, in this setting. All right, go ahead with the next question.
Okay. Well, next question, you're using the part from before. So you're going to try to prove that the integral between 0 and pi, we need to prove that the integral of x sine x dx between 0 and pi is equal to the integral between 0, it's...
Oh, sorry, I'm blocking. Yeah. Sorry about that, Javish.
So from the part before, you're going to use that it's pi minus x by sine x. With respect to x. Right, so you can expand the brackets. So you have the integral between 0 and pi of pi sine x with respect to x minus the integral between 0 and pi of x sine x with respect to x. So pi is a constant, we can put it outside. So we have pi, the integral between 0 and pi of sine x dx minus the integral between 0 and pi x sine x dx. Right, and this is your right hand side. This is taking your left hand side and proving the right hand side.
All right, and you can do the next part as well.
Yeah, so we need to prove that the integral between 0 and pi of x sine x dx, or I'm in red.
You're in the next sheet or you're on the sheet? Oh.
I went to the next sheet. Next slide. So we're required to prove that the integral of x sine x dx between the limits of 0 and pi is equal to pi. Right? So from the part above, which was part A of it, it gave us that the integral between 0 and pi of x sine x with respect to x is equal to pi, the integral between 0 and pi sine x dx minus the integral between 0 and pi x sine x dx. Right, so this was from part A of it. And we need to prove that this part is equal to pi. So bringing it around, we get that, so this here, there's an invisible positive one here, and this is minus 1. So when we bring over this entire thing on this side, we're essentially adding it together. So your constant turns to 2. So we have 2, the integral between 0 and pi of x sine x dx is equal to pi integral of sine x integral of sine x with respect to x between the limits 0 and pi. Right? So we're going to do this part now. So the integral of sine x is cos x, or negative cos x. Don't forget this. Between pi and 0. We can keep the constant pi outside. So we're going to substitute the upper limit first. So you have minus cos pi minus cos 0. Right? So cos of pi will give you -1. And cos of 0 is just 1. Right. A negative or negative will give you a positive. So you have pi, -1 by -1 is 1, plus 1, which is 2 pi.
Sweet.
So this have to come down to this. Yeah.
Let me see if I could just make it smaller. I wonder if I could do that. And yeah.
Yeah.
Is it smaller there?
Yeah. So let me just write it so that it's seen clearly. So it's 2 between 0 and pi of x sine x dx, which is equal to 2 pi. Right? So our aim is to find the integral alone. So we need to divide throughout by 2. So it's integral between 0 and pi of x sine x dx. So 2 pi divided by 2 will just give you pi. And that is what we were trying to find.
Cutie. Nice. So there was something I wanted to clear up in this question here. Sine pi minus x is equal to sine x when you're integrating between 0 and pi. That's the reason. Sine pi minus x is cos x. The integral of cos x and sine x between 0 and pi is the same thing. I think. It's the area underneath the curve between those two. And they are just mirrors of each other. So it's like that was trying to say, like, this is sine curve here, this little part, and this is the cos curve here between what was it, between pi 0 and pi? Was it pi and 2?
Just pi.
Just pi. Still not 100% clear on this sine x. Sine pi minus x cos x. 0 and pi. Still not 100% clear on this one, guys. Like, I know this is the reason, but I don't know why. I can't remember why. So I'll take a little review on it. All right, so let's go on to the next part of the question. Let's go on to the next part. I'll swing back to that question in the meanwhile. What I do, when I need a question. A chemical process in a manufacturing plant is controlled by this function where u and v are constants, given that m is equal to -1 and t is equal to 1, and the rate of change of m with respect to t is 35/4 when t is equal to 2. Yeah, when I use, yeah, right, that's what I did just now. But when I use the compound angle, you're getting cos x. I'll check it again just now. Given that m is equal to, Noreka is an ex-student who really kills it. Given that m is equal to -1 and t is equal to 1, and the rate of change of m with respect to that is that. All right, so we're back to an easy question here with a lot of marks. So this is double substitution again. Wait, now you're not a slides? What?
I don't know. I think so.
That is interesting. So I could just clear out. I'll just go back to the first side and start clearing out. See why I use my dossary earlier? Oh gosh, I'm rearranging them here. So a way to clear the page, and clear for you. Right, so we're back here. We can live with this. I believe this is a double substitution. When I just read it there just now, It felt like that. I'm not even going to connect on my iPad. Let me see if I can delete it. And I'm back to 19. Sorry for the delay, people. Normally, I use a software called Dosery, which is way in. Can I write here now? Nice. So I'll try to fit it here. A chemical process, we have M is equal to UT squared plus V over T squared. And we did one very similar to this. M is equal to -1 when T is equal to 1. And I hear somebody in the background a little bit there, Nelly. And the rate of change of M with respect to T, this is just a fancy way of saying dm dt is equal to 35 on 4 when T is equal to 2. Find the values of U and V are constants. So this guy and this guy, constants, variable. Why isn't it chat if you feel you could do this question? So you're trying to find the values of U and V. So let's just put in the two things. When M is -1, you have U. T is 1. 1 is a nice number to, 1 is a beautiful number to substitute. V over 1 squared. And dm dt. So we need to differentiate first. So dm dt in this case is going to be 2ut plus, is this going to be -2 v over t to the power of 3. You all could verify that one for me. And then this is going to be 35 over 4, is because we substituted now, right? Is equal to what we substituted. T is equal to what? I didn't write it. T is equal to 2. T is equal to 2. Type Y in the chat if y'all understand everything I do here so far. So when M is -1, T is equal to 1, I could go down here and get an equation. When dm dt is equal to 35 and 4, T is equal to 2. So we have 4u plus, well, this should turn out to be negative. No. Yes. Let's not jump the gun. -2 over 8v. And so we'll end up with a -4 there. I'm trying to conserve space earlier. Yeah, so how is that? I don't need an extra negative here by default. So that's 4. That's good. This is equation 1. I should multiply everything by 4. So I will get 35 is equal to 16u minus v. This is equation 2 actually. I didn't get equation 1 yet. Equation 1 was looking like what by? Equation 1 was looking like u plus v is equal to -1. Equation 1 was looking decent. So we solve these two simultaneously, and what we get? Solving these two simultaneously. Just want to move them away. Give myself some more space. We conserving land here. Where did T go on, says Mikhail. Anybody could ask questions. So the T disappeared. I think I make it a little too small there. But I make it a little too small. I get a little too happy. The T, when we substituted now, eh? Which T? This T here. We substitute all the T. Yeah, so we substitute the T. Anybody else have any questions? In both cases, we substituted the T. t is 2, so 2, nice. I didn't show the substitution line because it's pure maths. I just had a suffer and thing that way. So equation 1, equation 2, simultaneous, whatever way you want to do it, substitution method, simultaneous, elimination method. Pure math students sometimes strong on that, they like substitution. I would say just do your little elimination and go forward with your life now. So if I add both of the equations, I will get 70. So equation 1, and it working out really nice, plus equation 2. If I add both of the equations, and the reason I'm adding is because I'm seeing that will cause the v to disappear. So I'll get 17u is equal to 34. So u is equal to 2. And then substitute u equal to in equation 1. And you'll get v is equal to -3. Oh, and that's what I wanted, the values of u and v. So that was it. That was it for this question. 8 marks. So let's pray that they give you something like this. You know, nice little differentiate. CX, you having a press conference now? Let me see if my inside scoop tell me anything. Nothing from the inside yet. Rate out of 10 how much you understand this question. We're going to do the next question now. Nalini, I'm just going to delete some of these slides from before.
Okay.
So that we can get some space. Actually, let me just go back. Rearranging. It was too easy. That one was too easy. All right, so we're back to question 6. I'm just getting rid of some slides so we can do the question. So it's so hard to have to delete all the beautiful things that we do so far. All right, so you can go on to the next slide. And we're doing question 6. Given that, so you'll do this part and I'll do that part.
Okay.
Let's go back and meditate on the other question.
So 6 part A, part I, we're given that y is equal to the root of 4x squared minus 7. And we need to show that y divided dx is equal to 4x. So let's first find dy dx. So let's use the substitution. Let u be equal to 4x squared minus 7. Du dx, so we're going to differentiate u with respect to x. 4x squared will get 2 by 4, 8x, and well, the constants go away. And y would be equal to u to the power of a half. Right, so it will be the root of u. Let me write that out. It will be equal to the root of u, which is the same thing as u to the power of a half. And right, Mr. Springer, if you can just put
sorry about that. People like, sir, you can just tell me one
I didn't
time.
even
On this question here now.
Okay, right, so using the chain rule, we use the substitution here. We say that u equals 4x squared minus 7. We found du dx to be equal to 8x. We let y is equal to the root of u, which is equal to u to the power of a half. And dy du would be equal to u, well, you bring down the power, a half, u to the power minus a half. Right, so a half minus 1 is equal to minus a half. So we're going to use the chain rule. So the chain rule would be dy dx is equal to dy du multiply by du dx. Dx du, right? So that it cancels out.
du dx.
Did I do something? Oh, right. So when I say cancel out, I mean it cancels out. So you end up with dy dx, right? So dy dx, dy du is equal to a half u to the minus a half multiplied by du dx, which is 8x. Right, so we need to substitute back u into here. So u is equal to 4x squared minus 7 multiplied by 8x. So a half by 8 would give you 4. So it would be 4x by 4x squared minus 7. No, it wouldn't. I forgot the negative a half. Okay. Multiply by 8x. Right? So a half by 8x is 4x. Multiply by 4x squared minus 7 to the power negative a half. Now, when you have a negative in the power, you can divide by it. So you have 4x divided by the root of 4x squared minus 7 minus 7. Now, 4x squared minus 7, the root of 4x squared minus 7, that is equal to y. That's from this part here. This 4x squared minus 7 is equal to y, so we substitute that there. dy dx. So this will give you y dy dx is equal to 4x, which is what we will try to prove.
Vibes. Rate out of 10, how much you understand? Now the next one was you need to get d2y dx squared. And show that y is equal to dy dx is equal to 4xy. I feel, but that's not, so I'm not too sure about this because implicit differentiation are really part of the syllabus now. Y'all teachers teach y'all implicit differentiation. So let me just run through this question again one more time. Y is equal to the, I think that's coming unit 2, you know. Y is equal to the square root of 4x squared minus 7. Substitute u is equal to 4x squared minus 7 du. So you differentiate one time. Anytime you make the substitution, you differentiate one time. And all right, so y is equal to the square root of u. Following through with the substitution, differentiate now. So dy du is equal to half u to the power of negative a half. So this is the chain rule. This is the chain rule here. We reintroduce what u is. Wait, before we do that, we have dy du. We have du dx. So we apply the chain rule. Du dx is this one. We multiply the two of them and we reintroduce what u was in the first place. U was 4x squared minus 7. And we do a little change around here, bring this back underneath, put back the square root is negative, it's half, and you have 4x over the square root of 4x squared minus 7. So yeah, Anthony is right, implicit. So they wouldn't really bring a question like this. I think this is before the switch in the syllabus. So I don't think I'm going to do the next part. Because you could do it without implicit differentiation, but who wants to really go through the differentiation at this? Nobody really, right? And then simplify it. You now need differentiating this. You need to rearrange it so that you could see this come back out. So after you differentiate this, you put y, you substitute, then you square up this, and then you show that it is equal to 4 based off of this, which is not a nice thing to show. So implicit differentiation will be much easier. You bring this across and you get the 2y dx squared. But they're not tested right now. They're out of your syllabus. You all okay with that? So differentiating this way, we'll get 8d2y dx squared. How much marks they give you for that? That will let us know what we're supposed to do. 3 marks. So yeah, implicit differentiation. Even for this first part, I think they was really testing you to maybe do implicit differentiation on this side, maybe. Because it's just 3 marks. So anyhow, let's go on to the next part. The curve C passes through the point -1, 0 and its gradient at the point x, y is given by that. Okay, find the equation of C. All right, how y'all going? How many more questions y'all can do with us? What time y'all want to finish? We already here for 2 hours, as easy as it seems. The curve passes through the point -1, 0 and its gradient at the point xy is given by dy dx is equal to 3x squared minus 6x. Find the equation of C. What would be the operation for us to do here? Read the question. I'm gonna zoom out a little bit. Curve C passes through this point, and its gradient at the point xy is given by this. Find the equation of C. So we have the gradient function here. We have the gradient of the curve in terms of a function. So we want to go backwards to get the equation of the curve, because that's what they want, the equation of C. C here being the curve C. So yes, we're going to integrate. Well done, Antonio. We're going to integrate, and we give them some stuff. We give them -1, 0, which is like our values that we'll substitute to get rid of our constant of integration when we do this. So this is what we normally do in Add Maths, and it's showing up in Pure Maths. You just need to know what to do, right? So we started off with, let me see if I can get to that slide. Oh my gosh. I might use a different software. We just need a software that we could corroborate on. That may be less glitchy than this one. Am I here? Yes, I'm here. So we had the curve dy dx is equal to 3x squared minus 6x. Integration, lovely. So if we integrate dy dx with respect to x, we'll have to integrate this as well with respect to x. So we'll end up with y, and here we will end up with a lovely 3x cubed over 3 minus 6x squared over 2 plus a not so lovely C. Why isn't each other everybody good up to here? Well, the 3 and the 2 interacting, so you're getting y is equal to x cubed minus 3x squared plus C. But when x is -1, y is 0. When x is -1, y is equal to 0. So I can put 0 and I can put -1 in the dance. And what is that giving me for C? Plus C. This is just to discover what C is. Anybody get a value for C? This is giving me -1 minus 3 plus C. So are we getting C is equal to -4? Are we getting C is equal to +4? Yes. So therefore, put the answer up here. We're conserving pages out here. apparently we limited. Therefore, the equation of the curve, I wonder why they put a limit on the numbers. Why? I wonder what's the reason behind that. I can't see no reason behind that. It's y is equal to x cubed minus 3x squared plus 4. Rate out of 10 how much you understand this one. Find the coordinates of the stationary point. Nalini, so you could probably handle the next tool. I'm going to just delete some slides.
Yeah. So the stationary points occur when dy dx is equal to 0. So from the part before, we have that dy dx is equal to 3x squared minus 6x. So we need to equate this to 0. We have 3x squared minus 6x equals 0. We can pull out 3x from both terms. So 3x by x minus 2 will be equal to 0. So we have that either 3x equals 0 or x minus 2 equals 0. So when 3x is equal to 0, x is 0 divided by 3, which is 0. And when x is minus 2 equals 0, x is equal to 2. So those are the two x coordinates. We need to find the corresponding y coordinate. So when x is 0, we're going to substitute 0 into the equation of the curve, which we found in the part above. Y is equal to x cubed. So that's 0 cubed minus 3x squared plus 4. So that's minus 3 by 0 squared plus 4. So this will give y equals 4. And then when x equals 2, we need to find the y value. So y is equal to 2 to the power 3 minus 3 by 2 squared plus 4. So 2 cubed is 8 minus 12 plus 4, and that will give you 0. So the 2 points would be 0, 4 and 2, 0. So those are your two stationary points, 0, 4 and 2, 0. Right?
Nice. Everybody understand? So I guess we go on to the next one. Wait, coordinates of the stationary point determine the nature. So just to get the nature now. Yeah, Nalini?
So to find the nature of stationary points, we need to differentiate again. So we have that dy dx is equal to 3x squared, no, 6x squared, 3x squared minus 6x. 3x squared minus 6x times. And we're going to differentiate again. So that's the 2y dx squared is equal to 6x minus 6. So we're going to substitute the two x values we found. So we found that x equals 0 and x is equal to 2. So when x is equal to 0, the 2y dx squared is equal to 6 multiplied by 0 minus 6, which will give you negative 6. And negative 6 is less than 0. So when it's a negative value, we say that it's a maximum point, right? So the point 0, 4 would be is a maximum point.
Lovely.
And we do the same thing for when x is equal to 2. We substitute 2 into the equation we found for d2y dx squared. We get 6 by 2 minus 6 is 12 minus 6 will give us 6, which is greater than 0, so it's a positive value. And when it's positive, we say that the point is, it's a minimum point. So when x was 2, y was 0, so the point is 2, 0. 2, 0 is a minimum point.
Lovely. Now, I went back and checked the question again. That question that we do really troubling me. So since I do this question, I've not been the same since we do this question here. I've not been the same. Sign, I know what they're trying to do with this question as a math teacher, but it's not the same thing. Like, okay, what I did now, they say show that this is equal to that. That was the question for real, because that not seeming like it's supposed to be so. But just going back to that question, there's a mistake here now. I really think that it's supposed to be cos x, because according to the compound angle formula, sine of pi minus x is not sine x, as I was trying to force it to be between 0 and pi. Even when you check it with the graph, it's cos x. It's cos x. This question on my mind right through. So there's an error. And I stand in by that this is an error. And I could verify it. Let me see. Let me just do it. So like if I put x sine x, x sine x, and I integrate that between 0 and pi, 0 and pi, x sine x with respect to x. Let me see if it gives the same thing. Am I in radians? Pi. Let me see if it gives this. If it gives the same thing, well then, I'm wrong, and I need to go and figure out what's going on. Pi minus x. Error. Should I have an extra brackets? It gives the same thing. Pi minus sine x sine x. Why is this not cos x? Nalini, this is a question. This is a very interesting question.
How I looked at it was using the right-hand side to prove the left-hand side. But the question states to use the fact that the function f of x dx is so.
I was making a mistake. I was saying sine of pi is 1 and cos of pi is 0. So yeah, that's correct. Right.
Yeah,
yeah. So yeah. It's not cos x. So sine pi minus x is sine x. This sine of pi is 0. I have it written here. Look how much times that's going through that. Well, it's just one mistake, right? So sine pi, this is 0. So this goes. And if it was fighting on Rika just now, look, Rika have it here too. So this will be 1. The only thing is I have a negative. Cos pi minus cos x. I have a negative. That's the only thing. So yeah, side x. What a question. Definitely one for the books. All right, what's the next question in the dance? Cos pi is negative 1. What's cos? Cos pi is negative 1.
Yeah.
Very well. Right, so negative and negative. Get you in life. You get you in life, they were right, cover. And sketch the curve 0. Wait, this is the same question? Where were we at?
We finished part 3, part 4, where you have to find the coordinates.
Part 4, hence find the coordinates. I wasn't really paying attention in this question. I was just playing over this. So we have the coordinates of the stationary points, lovely. And we know which one is maximum and minimum. And find the coordinates of the points P and Q at which the curve meets the x-axis. So equate this to 0 and find the coordinates. All right. Since you're going on with this question here, I just want to finish this one out. You equate this with, I wasn't really paying it. So you equate this to 0 and you get your 2 roots of x. Then you sketch the curve showing the stationary points or showing up everything that you did. Okay, cool. Yeah.
Okay. So part 4, the curve meets the x-axis at P and Q. So the equation of the curve is y is equal to x cubed minus 3x squared plus 4. So when it cuts the curves at the x-axis, so that's when y is equal to 0. So when y is equal to 0, we have that x cubed minus 3x squared plus 4 is equal to 0.
Nice.
So we need to break this up. So let f of x be equal to this function. So let f of x be equal to x cubed minus 3x squared plus 4.
What are we trying to find here? The nature of each of the stationary points. Oh, okay. And we have the curve. Okay, great.
Now in part B, is it part B? Yes. They stated that the curve passed through the point -1, 0. So that means that when x is -1, y is equal to 0. Yeah?
Right.
So when f is equal to -1, y is equal to 0. I lost it. Right. So when x is equal to -1, it's x plus 1. So a factor of the function f is x plus 1. Right? So x plus 1 is a factor of the equation. But how I would...
So we could divide.
Yeah, long division.
So people who keep asking what is my background, it's a place in the Caribbean. That's the only hint I will give. The background, it's a place in the Caribbean. Just look for undersea statues, Caribbean.
X squared plus 4. So we're going to find, on top here, you will get a quadratic. So we're going to, this is called the factor term. So x into x cubed, we get x squared. So we're going to put it here. Right, x squared by x plus 1, so you get x cubed minus x squared. Let's subtract, so minus 3x squared minus x squared. You'll get negative 3x squared plus x squared, which is minus 2x squared. Bring down the 4, which you get positive plus 4. X into minus 2x squared is minus 2x. Well, we wouldn't bring down the positive 4. We need to introduce that term in x. So without changing the equation, we introduce plus 0x plus 4.
Nice.
So, right. So minus 2 by x will give you minus 2x squared. Minus 2 by 1 will give you, sorry, minus 2 by x will give you minus 2x squared, and minus 2 by 1 will give you minus 2x. Right, so instead of we bring down the plus 0x minus 2x, right, so we added it here, we are minus in here. So minus 2x squared plus 2x squared will give you 0, and 0 plus 2 will give you 2x. Bring down the 4, we get 2x plus 4. X into 2x plus 4 plus 2. So 2 by x will give you 2x. 2 by 1 would...
Which is a problem.
Yeah. Did I do something wrong?
No, I wasn't watching from the start. So let me see. I was playing around in the chat and thing with these guys. So this is correct, right? That was the equation. Y is equal to 0, and x plus 1 is correct. F of negative 1. So then x into this x squared, x cubed minus x squared. That's great. And then yes, and then negative 2x, negative 2x squared, negative 2x. That's also good.
Negative 3 plus...
So is either something wrong with the equation or the was it x squared? Where you get how you get this minus here?
X squared. Oh, yeah.
Yeah.
That's where I went wrong. X squared by x will give you x cubed. X squared by 1 will give you positive x squared. So when you minus... Right, so negative 3 minus x squared will give you negative 4x squared. Right, you're bringing down plus 0x, and then looking at it, you would multiply by minus 4x. So minus 4x by x will give you negative 4x squared. Minus 4x by 1 is negative 4x. Excuse me.
It's looking sweet now.
Right, so we're minusing. X squared terms cancel out. 0 minus minus 4 will give you 4x. Bring down the 4x plus 4, and then you get plus 4 on top here. So 4 by x plus 1 will give you 4x plus 4, and it would supposed to equal 0. So x plus 1 by x squared minus 4x plus 4 is equal to your equation of the curve. So we're going to this is the difference of two squares.
No, well, not difference of two squares. Just a
perfect not the
square.
Difference. Yeah. A perfect square. Let me write it here then. So you have x plus 1 by x minus 2 whole squared equals 0. So you get so from this is either x plus 1 equals 0 or x minus 2 all squared equals 0. So from here you get x is equal to minus 1 or x is equal to 2. So
right, so find the coordinates of the points P and Q at which the curve meets the x-axis. Okay, cool.
Right, so when x is equal to negative 1, y is equal to minus 1 cubed minus 3 by minus 1 squared plus 4. So that's minus 1 minus 3 plus 4, which is 0. And when x is equal to 2, y is equal to 2 cubed minus 3 by 2 squared plus 4. So that's equal to 8
0.
minus 12 plus 4, which is 0.
All right. So just to recap some things here, some of my thoughts with this. I kind of in the frame of this question, and I remember doing this question like a month ago with my class. Anybody from my class I remember doing this question? So dy dx is equal to 3x squared minus 6x. What we do? This is a long question. It's a long pants, but not that bad. Find the equation of c. So we integrated. I did the first part, right? We integrated. We got the equation of the line. Then find the coordinates of the stationary point. Coordinates of the stationary dy dx is equal to 0. We did that. We got 2x values, and we just substituted back, and we got the coordinates of the stationary point. Useful. They're gonna come in handy just now. So we find the coordinates of the stationary point because they're gonna make we draw the soldier. That's why I'm recapping. And then the nature of the stationary point. So we know when x was 0, it developed in a little maximum there. And let me just write out everything that we know here so far. Please pay attention with this. I'm sending out this in 1080p, Mr. Parallel. So you need to change the settings on your YouTube. Just change the settings, bro. So what we have so far, we have the maximum at 0, 4. And 2, 0, we have a minimum point. And the equation of the curve, we know the equation of the curve to be. So wait now, all the time you watching me in the first and talking, right? You and you just in the first. And then we have, did I say 4K? 1080p, just 1080p, 60 FPS. That's correct. If I said 4K, I was wrong. Did I say 4K just now? So the equation of the curve is x cubed minus 3x squared plus 4. And it cut in. Well, we didn't really need to go through this y part here because this is where it cut in the x-axis. So y is just 0 at that part. We'd already established y is 0. So the points would be -1, 0, and 2, 0. So now this is what we know. The question is asking us to sketch the curve. Sketch the curve C showing the stationary points. This man watching me in 240 240p, right? You are just do the math still. That is a soldier. I was just watching the screen and I seen on the screen. That is soldier. This man was just and working blind. Just for the love of pure maths. That one secured. Anyhow, so 0, 4 max, 2, 0 minimum point. Is a cubic polynomial. Them cubic polynomials, something is love to look like this. A cubic polynomial essentially birthed in something like this, right? So this is the graph of x cubed. So the minute you start to play around with it, it started to do things like that, things like this. It started to play around if you have x squared something involved. So we know we're gearing up for something like this. We also know where the maximum point is. The maximum point is at 0, 4. So somewhere there. 0, 4, right? We know where the minimum point is. It's at 2, 0. And that doesn't mean that's the minimum part of the graph. It just means it has a minimum point at 2, 0. So when 2, 0 here. Which is also something we could keep our minds open with, because that was actually a next root. That was the next part where it meet the graph in the linear. You with me there?
Yeah.
So if we in this we had the x plus 1, and we already had the x
minus 2.
Yeah, so we kind of didn't need to do anything. How much math left for that? The coordinates of the you could say, well, there's a minimum point. Why is in the chat if you all understand what I'm saying? There's a minimum point 2, 0, and this is actually meeting the x-axis at 2, 0, and then we already established that some other thing.
And the question was given that -1, 0 is a point.
It's a point. So yeah, they give you the two answers by the time you reach there. So, but you still would be a little skeptical because right now you have a
5 marks.
No, it's a cubic polynomial, so you would be looking for a third point now. It's only when we reach here, realize one of the roots was repeated. But what this would allow us to do is, I don't know what that allows. So yeah, maybe division would that be the best way still. Maybe. Or you divide and you just, however, this would not take long in an exam for a student to prime up. So you have a maximum point and a minimum point there. So you already know this is what's going on. But we need more instructions. -1, 0. We need to show that point as well. That's the next part where it cuts. So you want to show the stationary points and the points P and Q. That's where it meets the x-axis. So we have the two stationary points, which one of them happens to be where it meets the x-axis. So your curve looks like this. And this was a lovely question. X cubed minus 3x squared plus 4. Why isn't it chat? If you understand that, rate it out of 10 how much you understand. So I've seen pure maths people dying out, KO. We will definitely be back next week, probably the same date. And we would probably continue with some more calculus. What you all want? Continue with more calculus or our next topic? For really, just had to go through the process. The weirdest question that we came across, which kind of gave me a little problems, and I hate when something give me a problem on the live, is not a good look for the crew in spring and name nobody. Anyhow, was this the sign, and it was ridiculously simple too. But I got it out in the beginning, so anybody watching it in the beginning when I do it, sine of pi minus x is equal to sine x. But somehow I interchanging pi and 2 in my mind, so I was like writing pi there. Look, I even have it still written there. That's not pi, that's pi and 2. So I was just really struggling to figure out that question there. Let me just sort that out one time. Oh my gosh, where is it? So this is actually pi and 2. Pi is here. Yeah, so the sine of pi minus x, sine of x, same thing. Bam, 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 and answer that question. So we get to see some repetition happening. What you're saying, more calc. Could you do unit 2 calculus? Yes, we're going to do that too. I'll probably introduce that on Fridays. Even though I just came today, let me do some trigs, please. Trigs. I do trigs yesterday. I do some trigs yesterday for the day before yesterday for Ad Maths. I was in that. So trigs for pure maths have a little more sting. So yeah, we could probably do some trigs too. We'll definitely do a really long session, like right before exam. I think that will, help everybody. And Miss normally behind the scenes, so this will kind of help her to be in front of the scenes dealing with the likes of students in the Caribbean. Okay, so it was really nice of you all to be here. You all can press like on the video. We'll come back again next week. We'll probably do some more calculus or maybe some more tricks. I'll probably vote on my Instagram. You all can check me out on Instagram at the Student Hub. If you like this style of teaching where we converse and making sure everybody understand, we will be starting our Unit 2 classes in August. So you can sign up. You can sign up for the Unit 2 classes. Javish, you can just type the number there. Javish know that number by heart by now. So yeah, just WhatsApp that number. Anywhere in the Caribbean, like he probably Instagram information. You can WhatsApp that number and sign up to the classes. There you go. And we definitely coming through with an SEA stream. I will probably do that tomorrow, please God. On Friday, I wanted to do it today actually, but I'll do that tomorrow, please God. I have a whole set of mean questions lined up. Nazri, this man in SEA and in my life. Nazri Scott, I know that name. What are you doing here, boy? You're far from home here, boy. You're far from home. Anyhow, yes, look behind you. I see you. Hey. Thanks a lot, thing. Every live thing. Blessings, love and blessings. Anything else to tell all you, boy? Just register all yourself for the classes. When August reach, find yourself in the Student Hub is the best ever. And if things hard and thing and maybe you have the cash, what you can do in the meanwhile is go on the Discord channel. And to go on the Discord channel, just follow my Instagram and the Student Hub Instagram. The link is in the bio. I feel like it's enough talk. Ms. Nalini Prasad, it was a pleasure to have you here as well on behalf of the students. Thank you for taking the time out.
It was a pleasure.
You're outside. Nancy, say you fed up with these questions, so they have more letters than numbers. Anyhow, later.